Hello, Algebra 2 students. Today we start a new unit. Let me go back through this video. We're going to start a new unit, and we're going to start with video. So, you know the routine. What am I going to ask you? What do you notice and what do you wonder? Here we go. Okay, what do you notice? I hope you said you noticed things like there are numbers written on the tennis balls. And I hope you noticed things like some of the serves went inbounds and some of the serves went out of bounds. And I hope you wonder things like, why are there numbers written on the tennis balls? And why did some go in and some go out? Okay, let's watch the next part. Okay, so do you see that the tennis ball with -1 was a legal serve? The tennis ball with 2 was a not a legal serve because it was out of bounds. You notice there was an equation. We're going to go back just a minute.
I think I see how this works.
Okay.
This one's got this.
So what did he do? He looked at the equation on his tennis racket. And now he knows which numbers are going to go inbounds and which ones are going to go out. Okay, so let's go back a minute and look at the equation that was on his tennis racket right there. This is a function, it's a polynomial. Polynomial, word poly, P-O-L-Y, meaning many, and nomial, meaning terms. How many terms do you have here? There's x to the third, that's 1. Negative 3x squared, that's 2. Negative x, that's 3, and plus 3. So we have 4 terms. So do you remember the words like monomial for 1 term and binomial for 2 terms and trinomial for 3 terms and just polynomial if it's 4 or more? So we have this polynomial. We have numbers written on the tennis balls, but I wonder what the relationship is, why some of the serves went in and some went out, and if it has anything to do with those numbers. I know that I can graph that polynomial. And it was x to the third minus 3x squared minus x plus 3. And what were the numbers? Do you remember the numbers on the tennis balls that were inbounds? Was -1, +1, and 3. Wonder if that has anything to do with this graph. Those 3 points are called x-intercepts. They're also called roots. They're also called zeros. Why do you think they're called zeros? Because for every one of those points, it's where the y is 0. So in the tennis balls that he was hitting, The ones that were a solution or a zero or a root or an x-intercept were landing inbounds, and the other ones were not x-intercepts and not solutions and not roots, and so they were out of bounds. So we're going to look at polynomials today. We're going to start with just kind of a review. We're going to look today at adding, subtracting, and multiplying polynomials. Okay, so do you remember? Here's the word polynomial. Means many terms. Monomial is one. Binomial is two. Trinomial is three. And if it's four or more, you just call it a polynomial. Okay? You could say a 4-term polynomial or a 6-term polynomial or a 5-term polynomial or a 12-term polynomial. All right, so what do we know about these terms? We have like terms. That means the same variable and the same exponent. You can only add or subtract like terms. So let's say if we have 2x squared plus 3x plus 5 plus 2x squared plus 4x minus 3. What are we doing to these two polynomials? We're adding them. So take your ones that have the same variable and the same exponent and add them together. Do you notice that the coefficients, the 2's changed? The variable and the exponent did not change. So the x squared part didn't change. When you add or subtract, the variable and the exponent stays the same. The coefficient changes. What about our x terms? We have plus 3x plus 4x. Add those again. The coefficient changes, the variable stays the same. Then we have the constant terms. That means it doesn't have a variable. 5 plus negative 3. So 5 minus 3 is 2. How do we know we're finished? There are no more like terms to combine. Okay, adding is really easy. Add the ones that have the same variable, same exponent. Okay, change the coefficient. Leave the variable and exponent the same. So what if we had 4x squared plus 2x minus 3 minus x squared plus 5x minus 6. Now what's between the two polynomials? Okay, so now we want 4x squared minus 1x squared. 4 minus 1 is 3. 2x minus 5x. 2 minus 5? Negative 3. Negative 3 minus negative 6. What happens to this minus and this minus? They change to plus. Negative 3 plus 6. I didn't mean to make that come out all threes, but it did. That's adding and subtracting. It doesn't matter how many terms you have in each polynomial. You can only add the like terms. Let's say, what if we had 4x squared plus 2x plus 5 plus 3x minus 4. Do we have anything to add to the x squared term? We don't, so it stays the same. Add your 2x and your 3x, your 5 and your negative 4. Okay, that's adding. Adding and subtracting, you can only add or subtract like terms. All right, let's take a look at multiplying. This is a review for you from Algebra 1, and you probably used it some in geometry. When you multiply, we have something called distribute. Where you take what's on the outside of the parentheses and multiply it by each term inside. None of those are alike. We can't combine them. You might have a variable on the outside. You distribute. Do you remember what to do with the exponent? It's going to be 8x to the 5th plus 12x to the 3rd minus 16x squared minus 28x. Multiply the coefficients, add the exponents. Okay, so what have we talked about? We've talked about adding and subtracting. We can only add or subtract like terms. We've talked about distribute. Okay, and if you multiply one variable times another variable, what if we had when you distribute this, it's going to be 6xy squared plus 4x squared y minus 8x. Okay, you can't add or subtract if they're not like terms, but you can multiply. And we'll get into the division later. We're not going to do that today. All right, there's one more thing with multiplication, and that is when you have binomial. Binomial is two terms. So if I had like x plus 4 times 2x minus 3. Now, there's a couple of ways Algebra 1 teachers teach this. Some of you learned FOIL, first, outside, inside, last. First, outside, inside, last. So it's basically distributing, but first two terms are x and 2x. The outside terms are x and negative 3. The inside terms are 4 times 2x. And the last two terms are 4 times negative 3. Okay? Now, this time, we can't quit too soon because we do have some like terms. This negative 3x plus 8x. Those have the same variable and same exponent. So we would combine those. And now we're done. Some of you learned that by box method. We would multiply x times 2x, 4 times 2x, x times negative 3, 4 times negative 3. 2x squared. Combine these two. Minus 12. You might have a longer distribute, like so you can either make a bigger box x squared times 3x would be 3x to the 3rd. Negative 4x times 3x. 6 times 3x. Oh, this would be squared right here. Then x squared times 2. Negative 4x times 2. 6 times 2. You have 3x to the 3rd. X squared, you got negative 12 plus 2. X's, you got 18 minus 8. And then plus 12. Or you could distribute that and do 3x times x squared. 3x times negative 4x. 3x times 6. 2 times x squared. 2 times negative 4x. 2 times 6. And then combine your like terms. Do you have any more x to the thirds? Nope. X squared, you got minus 12 plus 2. X's, you have 18 minus 8. And then plus 12. Look, we got the same answer. So if you want to distribute, that's fine. If you want to use the box method, that's fine. That is a brief overview of add, subtract, and multiply polynomials. You have an assignment in your Savas Realize. It's 8-2, and it's all the same stuff. Add, subtract, multiply. Use your question help if you get stuck. Good luck, and goodbye.